Let's do a transformer calculation. So we're going to do this one. So we're given 320 kVA. It's the same. The power of a transformer, three-phase transformer, is connected in a star delta connection. So if it's connected in a star delta, that means the star is for the primary and the delta is for the secondary side. So the delta connection secondary side, which is phase voltage on the secondary side, is 380, and the transformation ratio is 10:1. So on the delta we have line secondary is equals to this phase secondary. Then on star side, the line secondary, it's equals to √3 primary, because it's primary side. Line primary equals to phase primary. So the transformer ratio, which is you have 10 in this side, then you have 1. That's the ratio that is given here. So we are required to find VLS on number 1. So V line secondary, which is equals to V P phase secondary, which is this side. So on the primary side we are looking for V secondary on the secondary side, and also line secondary, and then the line primary and phase primary. So when you are doing transformer calculation, you have to find these two, the line side and the voltage, and then you have to check whether it's a star or it's a delta. We are primary side. So let's continue. Because of this equation we are given a secondary voltage, so they are equal, so we just write 380. And then number 2, we are looking for phase supply phase voltage. So we're going to use a ratio because we are looking for this one here. So from primary to secondary side you have to use a ratio. So phase primary over phase secondary equals to the ratio of the primary side and the secondary side. So we are given 10:1. So here we're going to make VPP the subject of the formula. Phase primary N1 over N2 multiplied by, then the ratio is 10:1, so 10 multiplied by the voltage, which is phase secondary, is 380 volt, then which is equals to volt. So this is phase voltage on number 2. Number 3, so we are required to find the line voltage because we have already found this one. We are looking for this one. It's a star, so on a star there's a √3 here. They are not equal. unlike this equation. So on a star we have an equation like L line primary equals to root 3 phase primary. So we already have phase primary for number 3. So we're going to say line primary equals to the root 3 according to the formula. Phase primary, which is root 3 multiplied by 380, which is multiplying 380 we are going to get something like 6547 voltage. So let's do number 4. We are looking for load current. We're going to use this formula. The power is given. This represents the power and the voltage in the current, making ILS line secondary equals the subject of the formula. So we're using root 3 multiplied by the given then calculating this one. The 320 is this one, the power of a transformer. This is given there on top. This represents the power, and then this is the equation that we use. So calculating this one, I get 486,2 amps, and then number 5, we're going to 5. It's using the the secondary side of delta, because it's delta there. A delta current is like this, using this equation when you check the delta equation for delta. So it's not the same as, because we already got this one can make line phase current equals to line, making IPS the subject, divided by where root 3, so you get 486,2 divided by root 3, then you get 280,7 amperes. So this is how you calculate. So for more video like this, you can just visit on the address that is given above. And thank you for watching. So we can explain more on the next coming video because of time.